Good evening, ladies and gentlemen, and welcome to the 13th event in our Engineers National Development CPD series for this term, run by the West Region. This is our 13th event, as I've said, and we've had circa 40 speakers to date across all 13 events. We have three excellent speakers lined up for tonight. The first is Cian McGuinness from RPS Consulting Engineers, who's going to speak to us on the proposed Galway to Athlone Cycleway. We have Colin Hedderly from Irish Rail, who's going to present on the Lough Atalia Railway bridge upgrade and cover the history of the 170-year-old bridge and recent repair works, where Irish Rail used improved sustainability through design driven by strategic thinking and the use of new materials, which lower life cycle costs. And finally, we'll have Roy Harford from the National Transport Authority, who's going to present on the Connecting Ireland Rural Mobility Plan with a focus on the West Region. So I'd encourage you to put your questions to the speakers in the chat box as the event unfolds, and we'll have all three speakers first, and then we'll go to as many of the questions as possible, and we'll do the Q&A session at the end. So I wish you an enjoyable event, and I'll hand over to our first speaker of this evening, which is Cian McGuinness from RPS Consulting Engineers. Thank you.
Thank you, Justin. Hopefully my screen is sharing okay.
Yes.
Okay, well, look, my name is Cian McGuinness. I'm the project manager for RPS Consulting Engineers on the Galway to Athlone Cycleway. So today I'm just going to give a quick 20-minute overview on the project, on where we are in its development, and a short little overview of what the next steps for the project are. Firstly, a little bit of background to the cycleway. It's part of the, I suppose, larger Galway to Dublin cycleway. That's a proposed cycleway all the way from Dublin to Galway, or Galway to Dublin, depending on how you look at it. That project is essentially complete between Galway and Athlone. So, Dublin and Athlone. The project as a whole sits within the Eurovelo framework. The image on the left there shows the Eurovelo network. That's a network of leisure cycle routes all throughout Europe. Two of those routes are in Ireland, one which goes along the south and western coast. And the second route is Eurovelo 2, the capital's route, that is planned to stretch all the way from Galway, and up to recently was planned to go as far as Moscow. I'm not sure if that's still the plan, but it does show that the Galway to Dublin route and the Galway to Athlone is part of a wider network of European cycle routes. I think I've lost one of my slides. One of the documents that sets out the framework for developing the project is the Greenway Strategy that was published by the government in 2018. That sets out the criteria for developing national and regional greenways in Ireland. And the Galway to Athlone Cycleway is very much a national cycleway. It specifically mentioned Galway to Dublin as being having the potential to be a greenway of scale and of international appeal. And it sets out the 5 S's that guide the development of greenways in Ireland. And those S's are that the greenway should be strategic, it should be scenic, it should be developed in a sustainable way, it should be substantially segregated and shared use, and it should offer lots to see and do. The National Development Plan also referenced the Galway to Dublin Greenway, and it mentioned it as being an iconic coast-to-coast greenway that is a priority for the government. So the objectives of the Galway to Athlone section that we set out at the start of the project: we'd like to increase cycle tourism in the region. We hope that by doing that, we'll create local employment through either new or expanded enterprises. This in turn will benefit local communities. We'd like the cycleway to increase the number of Irish people that partake in active leisure, encourage a general shift from cars to bikes. We want to deliver value for money. We want to deliver a segregated and safe cycleway. We'd like to use state-owned lands where practicable, and minimise impacts on agricultural holdings where we do have to traverse private land. We hope that the Greenway will encourage people to experience the countryside and attract users of all abilities, and also that it would integrate well with other Greenway and tourism initiatives and other infrastructure. In order to, I suppose, pick the route and start the design, we first looked at some board folio research that was prepared by them in the middle of the 2010s, where they did some market research with potential users of long distance cycleways. And they asked the question about what makes a good cycling tourism trail, which is what we're looking to deliver. And the results are shown in the little graphic there on the left, where people express preferences for different aspects of a cycleway. And the high level take from that was that people in general preferred circular routes. That's not much use to us, I suppose, given that our brief was to go from Galway to Dublin. People like to be away from it all rather than in towns and villages. There was a preference for segregated and traffic-free routes rather than using on-road facilities. Most people would like to have relatively short distance routes, sort of less than 50 kilometers per day. Unsurprisingly, flat gradients were preferred by cyclists. Most people prefer to rely on their own transport, and people would prefer to have a variety of other activities available around the Greenway and not focus completely on cycling. And there was a strong preference at the bottom, 44%, for taking the most scenic route rather than the most direct route. So a lot of those preferences, I think, fed into the Greenway strategy, setting out that the Greenways should, be scenic and substantially segregated. So in the context of choosing a route for Galway to Athlone, we asked, well, from a user's point of view, what would a good route look like? So we set out to choose a scenic route that would be mostly rural. That's somewhat easy between Galway and Athlone. It's a very rural area. We'd like to have a good variety of scenery because it's not going to be a one-day trip for people. Depending on the route, it would take 2 or 3 days to traverse the route. So a good variety of scenery is important. We need to visit larger towns along the way so that there's overnight facilities and things to do in the evening. We'd also like to provide things to do during the day. So we'd like for the route to visit parks, heritage centres, and facilitate people taking part in other activities. We'd like to have smaller facilities every 15 kilometres or so for refreshments. Ideally, we'd also like to serve local needs. So we'd like to connect schools, parks and sports facilities. While the Greenway will go from Galway to Athlone, we are also conscious that not everyone will travel the whole distance from Galway to Dublin. So we want to provide interesting shorter trips for people not interested in doing the whole thing. We'd like it to be accessible and not too taxing physically. We don't want to set up something that's suitable for the Tour de France. And critically, we want it to be segregated from traffic, both visually and physically. So we want to have it as a rural experience, similar to the picture that's shown there. At the start of the route option development, we firstly mapped state-owned land in the area. So that's a map of the study area for the scheme, with Galway City on the left, Athlone in the top right. And the green hatches there are areas of state-owned land. So that's principally Cuilcha, Bordnamona and the ESB. It also shows the railways and motorways and other existing roads in the area. So while there is a good bit of state-owned land, particularly in the south, in the Sclevocties and along the Suck and the Shannon, there isn't a very good state-owned link other than the motorways and the railway. With that in mind, we developed 5 broad route corridor options for the cycleway, and these were developed in early 2021 and were put out to public consultation at the time. So the routes are shown there. The route corridor options we selected are shown there. So We had routes going from Galway to Mount Bellew, down into Ballinasloe, and then into Athlone that way. That'll be the green route. We looked at a route paralleling the existing Galway to Athlone Railway. That's the brown. The blue route went from Galway, Athenry to Ballinasloe, down to Shannon Bridge and up to Athlone. Our yellow route went via Athenry, Lough, Portumna, up to Shannon Bridge and into Athlone. And the red route went along the coast of Galway Bay down to Kinvara, through Gort, across the Slieve Aughties to Portumna, and then up to Athlone that way. We looked at these again from the user perspective to see what kind of what an itinerary on each route would look like. So in Route 1, we worked out that the route would be about 140 kilometres long. We typically think that somebody on a leisure cycle will cover roughly 60 kilometres a day. So 140 kilometres could be either 2 or 3 days to do. And Mount Bellew is pretty much in the middle of that route, and that's where we would expect people to make an overnight stop. Routes 2 and 3 were somewhat more direct, 120 kilometres, so that's quite easily a 2-day trip, with Ballinasloe as the likely overnight destination. Route Corridor 4 is about 180 kilometres, so we consider that to be a 3-day trip, going via Lough for the first overnight, then to Portumna, and then the last day up to Athlone. And somewhat similarly, Route 5 would head down to Kinvara and Gort, with that being a first overnight, across the Slieve Aughties to Portumna, and then day 3, Portumna up to Athlone. We also looked at how the various route options might tie in with other planned or at least suggested greenways or other kind of links like that. We mapped them there. So the bright blue line along the coast is the Coastal Cycleway. That's part of Eurovelo 1. And that links in with all our routes in Galway, and links in with the red route at between Gort and Kinvara. There's a proposal or a suggestion for a greenway from Sligo down towards Athenry that would link in very well with the green route and the other routes that pass through Athenry. Excuse me. And on the east side, then there's a variety of other greenways and cycleways heading east from Dublin, and they would tie in with any of our routes either in Athlone or potentially in around Banagher. Within those 5 route corridors, we set to do some candidate routes within them so that we could establish what would be involved in developing a greenway in each corridor. And we sought to piece together how we could use existing infrastructure such as forest roads, existing trails, low volume roads, that kind of thing, as well as potentially using the Bord na Móna railway infrastructure between Athlone and Ballinasloe. We looked at a route. Route 2 was completely parallel to the existing railway line, and we divided up the likely greenways in each route into this type of sections, just principally to see how much private farmland would be used in each. And the breakdown is shown there, and it shows that even though routes 4 and 5 are significantly longer, most of that extra distance is covered by existing forest roads and existing trails. The routes went out to public consultation in February 2021, and we got a very large response with, I think, over 11,000 submissions from all around the counties. There was an overwhelming positive response from the communities and the towns and villages. And particular towns and villages made a great effort in, I suppose, advocating that the Greenway should come into their locality. We had less engagements from landowners and farmers who were very concerned about the impact that building a new greenway through their land. Route corridors, pretty much all the corridors 1, 3, 4, and 5 received very strong support. But we had emphasised that it wasn't an election. It wasn't simply the case that whichever corridor got the most submissions would be the winner. And we got particularly strong representations from Athlone Town and Ballinasloe, both advocating that the Greenway should pass through those towns. Okay, apologies, I just had misfiled my presentation. If it's okay, I'll double back very quickly. Just the project team working the project. We have Transport Infrastructure Ireland, who have the overall responsibility for greenways in Ireland. We have Westmeath County Council, who are the project promoters. And then we're working at Roscommon County Council, Galway County Council, Galway City Council, and also Offaly County Council. So after all of that analysis and the public consultation, we selected our emerging preferred route corridor, which hopefully is showing in front of you there as a green image. So we selected route corridor 5, the red corridor. So that travels from Galway City through Iarnród, Kilcolgan, down through Kinvara, through Cool Park into Gort, across the Lough Atalia Mountains, and into Portumna via Portumna Forest Park. It then travels up the bank of the River Shannon towards Meelick, then into Shannon Bridge, where we cross the Shannon on the Borden-Mona Railway Bridge, and then back over the Shannon on the old stone bridge in Shannon Bridge, and then proceed from Shannon Bridge to Athlone, primarily along the shortly to be disused Borden-Mona Railway. So at a high level, the reason it was Route 5 was selected was it was felt that it would best deliver on the scheme objectives. It delivers outstanding scenery and a good variety of scenery along it. So we pick up the coast of Galway Bay, we go through parts of the Burn, we go through the Burn lowlands around Gort, over the forested hills of the Lough Atalia. We visit the River Shannon Callows and Lough Derg, and then pass through the peatland landscapes of Borden-Mona. So we've a lot of high quality landscapes and a good variety of topography. We have a lot of highly rated attractions along the route, including a lot of parks and nature reserves, and also a strong cultural heritage experience. We do use a good proportion of state-owned land, and it does present a nice 3-day cycling journey from Galway to Athlone. Another reason was that the 55-kilometre length from Shannon Bridge to Portumna, that also contributes to enhancing connectivity along the Shannon, which is a key strategic initiative of the Shannon Tourism Master Plan. I should emphasise we've picked an emerging preferred route corridor, not a specific route. So an example of what I mean by that is shown there on the right. In some areas where we're relatively confident where the Greenway will be, we've shown a fairly thin line. And in other areas, we've shown quite a wide blue hatched area. And our next task is to engage with the landowners and stakeholders within those wider blue areas to best establish what's the optimum route to the blue areas. That's the stage that we're at now, and we'll be working through picking that very final route for the rest of this year and delivering the preliminary design and environmental impact assessment this year and throughout 2023. I think I'm at my 20 minutes, so I'll park it at that. Thank you very much, and I'll be here at the end of the session if anyone has any questions on what I've just presented.
we'll move to the next speaker, which is Colin Hedderly from Irish Rail, who's going to speak to us about the bridge upgrade works to the Lough Atalia Railway Bridge. So Colin, the floor is yours.
Thanks, Justin. Good evening, everyone. Can you hear me okay?
Yes.
Good start. Let me just share my slides. Is that coming through?
Yeah.
Perfect.
Okay, good stuff. Okay, good evening. So the challenge for engineers working on historic structures is how we maintain and modernise them to ensure they deliver day in, day out. This presentation is about the refurbishment and upgrade works undertaken to Lough Atalia Railway Bridge in Galway. I'm going to talk a bit about the description and the brief history of the bridge, which I didn't know before I started looking into for the presentation, which is interesting. A bit about the foundation investigation, structural defects repairs, the rethinking of track work designed for sustainability, the replacement of the track work, and then the Q&As at the end. Okay, Lough Atalia. This is the location overview with the Lough Atalia Bridge and the immediate proximity with Kent Station in Galway on the bottom left and top right towards Dublin. The bridge originally built 1850-51. It's a 5-span wrought iron structure across a tidal watercourse, and originally had a rotating opening spans above central pier. And this is how it rotated. Now, an overview of how Irish Rail, we break down the bridge in our asset management structure with parent assets and with sub-assets. So the bridge here is UBG 170 as opposed to UBG 171, the Lough Atalia Road Bridge. So I'm talking about UBG 170. And we have 5 spans here numbered. We always number spans from the Dublin end. So we've 5 spans with 3 piers, and I'll get onto that because the span above the pier, the central pier, is effectively spanned, and that's our 3rd span there. So that's how we break down the bridge in terms of our asset management. Bit of the history now. The key people, there were 3 really. George Willoughby Hemans was chief engineer of the MGWR. Okay, his obituary is available from the ICE library. He was president of the Institution of Civil Engineers of Ireland, 1856-58, where incidentally he was first to start the tradition of giving a presidential address. Then we've William Dargan, a well-known, arguably most important Irish engineer of the 19th century, certainly most important figure in railway construction. Dargan built the first railway line in Ireland from Dublin to Kingstown, now Dunleary, and went on to build over 1,000 miles of railway lines in Ireland. More information on him can be found on the Engineers Ireland website. And thirdly, we have Sir William Fairburne, Scottish civil engineer, structural engineer, and shipbuilder. Now, Fairburne was the structural ironwork contractor for Lough Atalia, and he supplied his patented box girder design for the rotating opening span from his foundry in Manchester. He was one of the first engineers to conduct systematic investigations into failures of structures, and he was a lifelong learner. Fairburne's famous for developing the box girder for the Britannia Bridge to span the Menai Straits between Anglesey and North Wales in 1850. And this is significant because 1850-51 was when we were building the bridge in Lough Atalia. So I have a short video from the ICE about the story of the development. I'll just share this now, the story of the development of the box girder.
A box girder is a very boring sounding thing. The reason I really like the story, it's like a detective story, and there are 3 characters. There's an engineer called Robert Stevenson, who's the same Robert Stevenson who was involved in Stephenson's rocket with his dad, George. There's an iron worker called William Fairburne, who just operated this wrought iron yard populated probably with lots of young urchin-like kids who were bashing in rivets, and you can imagine flames and sparks all over the place. And then there's a more cerebral academic fellow called Ethan Hodgkinson, who was a professor at University College London. Robert Stevenson got the job to run the railway from London up to Anglesey. One of the big natural obstacles in the way was the Menai Straits. You have to go across about a mile of very fast-flowing tidal water. To get across this, you had to build a bridge of some sort. And to carry the trains in those days, which weighed several hundred tons, you needed something fairly sturdy. And at the same time, the tide was going in and out, the currents were really strong, the water was very deep. And so Stevenson came up with this idea of building the bridge in 3 sections, but each section being really, really long and being floated out and then lifted up into position. They said, well, that's the proposition. We'll just make these things. They'll be 500 feet long. We'll have 3 of them or so, and we'll lift them up and it'll all be fine. And of course, nobody knew how on earth to do it. It had never been done before. So Stevenson got hold of Fairburne in his ironworker's yard and said, right, I want you to do some experiments. They did some experiments on the strongest thing they could think of, which was a tube. And they did quite big experiments, maybe 20-foot long pieces. And they just did loads and loads and loads of these things. They loaded them up with as much as they could hang from the middle. And every time they broke, they added a bit, and another bit, and another bit, and another bit. So what happened was the thing bent like that, and the bit in the middle buckled. And so they put some more material there, and then did it again, and it parted company at the bottom, so they put some more material there. And they got through this sequence in about 6 weeks, at the end of which they couldn't carry as much as they wanted. And so they had to do something else. So they said, well, instead of circles, we'll do squares now, on the basis that if you make something square, you've got as much material as far away from the middle as possible, so it's likely to be a little bit stronger. They went through another sequence and started making bigger and bigger experiments until in the end they made them 75 feet long, and they were 8 feet deep, some of them. These are huge things, just to test. You can't imagine many universities nowadays doing these things. And they got them stronger and stronger and stronger. And they gradually developed this language of really high strength and very low material. So really high performance, basically. And by this time, these things had got so big that they realized that instead of running the trains on the top, they were so huge, they could run the trains right through the middle. They said, right, that's it, that's what we're going to do. And the reason I like it is it was a fantastic piece of research that actually turned out to be so valuable that we're still using the knowledge 170 years later. Lots and lots of road bridges, lots and lots of railway bridges, all sorts of things have the box girder as their principle. We've used it lots of times in other forms, sometimes V's, we tune the shape of it. But the most recent and most successful time we've used it was we did a bridge over the River Tees at Stockton called the Infinity Bridge. And that is made out of very tight box girder sections which build on all of the knowledge that originated from Stevenson and his crew 170 years earlier. Had they not started on that journey, we probably couldn't have built this very, very slinky bridge nowadays. When you see these things standing there, they look as if they've always been there, and you forget how much groundbreaking thinking has to go into getting them there in the first place. So I think the first thing is to learn the value of research. It's something which is not to be sniffed at, not to be thought of as being extravagant, not to be thought of something just for pharmaceutical companies. It's really central to moving human knowledge forward. And the box girder bridge is such a fantastic invention, big scale, and it's affected so many people and it's opened up so many communication routes that it just becomes part of the fabric that we all take for granted. But actually, there were some really bright people involved in putting it together in the first place.
Okay, so I'll go back to my presentation. There we go. So I thought that was a good little video just to tell the story, really, and obviously how Lough Atalia fits into that with the connection with Fairburne. So also in the research newspapers, they're a very useful resource for information available online, and actually found they've some quite wonderful names, the Mayo Constitution and the Galway Vindicator. But the newspapers, they paint a picture about the bridge at the time of construction, The railway opened on Wednesday, 6th of August, 1851, and there's an account of the first train in the Galway Vindicator. But this report during construction on the 18th of March, 1851, from the Mayo Constitution, I think is more interesting. It says, the attention of many of our citizens has of late been drawn to the increased activity displayed on the works of the railway adjoining the town. Mr. Fairburne asserts that the box form developed combines greatest strength with greatest economy of materials. Lough Atalia Bridge is described as being a Menai bridge in miniature. It mentions the deflection of the Menai Bridge under the passage of a heavy train is exceedingly small, and we are warranted in asserting with confidence that the bridge across Lough Atalia will scarcely exhibit any deflection. Also, it says, we may remark that to the professional man, this bridge before us ought to be extremely interesting, as we believe it is the first swivel bridge of such great span that has been constructed on this novel principle. So a few things there, obviously convincing the public that the new construction, this newfangled railway and the bridges are safe, but also recognizing the engineering that was being done in Galway at the time. This is the only photo I found that shows the original Fairburne rotating span. It's an image from a glass plate negative circa 1909, taken by Harold Fail, who's a founding member of the Irish Railway Record Society, and this has been kindly supplied by the Record Society. Now, the 1857 book, A Practical Treatise on cast and wrought iron bridges and girders by William Humber, describes Lough Atalia Bridge as follows. The bridge consists of 4 spans, 2 of 40 and 2 of 60 feet in the clear. The girders extending over the central pier across the larger spans form a double swing bridge resting on conical rollers, which revolve on a circular iron platform, firmly embedded on the masonry of the centre pier, which is 34 feet in diameter and founded on solid rock at the narrow entrance which leads from the harbour to the loch. The entrance is nearly dry at low water, but the Admiralty, as conservators of the navigation, conceiving that at some future period the loch might be converted into a harbour or floating basin for shipping, insisted on the bridge being movable, so as to give an opening of 60 feet clear on each side to admit vessels of the largest class. In addition to the railway, the government further stipulated that there should be a footpath for the convenience of the military in passing between the town and the opposite side of the loch. Here I've just come a bit closer to see the detail of the rotating span. You can see the wheels of the turning mechanism. William Humber continues this description. It will be seen that the 2 main girders of the swing span are of the parabolic form, each being 157 feet long and decreasing in depth from 6 feet in the middle to 3 feet 3 inches at the ends. Each of these girders is composed of wrought iron plates and has the material arranged in the form of a cell at the top to increase its power in resisting compression. The plates, of which the cell and vertical sides of the girder are composed, are 9/16 of an inch thick over the centre pier, decreasing from that point towards the ends of the girder, where they're only 6/16 of an inch thick. Here's a drawing of the rotating span. It's from 1931. It's the oldest drawing that Irish Rail have of the bridge. It shows the detail of the 157-metre long box girders. Now, the movement was affected by windlasses, which work a wheel and pinion. 2 men standing upon the side of the pier move the platform with ease, winding it round so as to leave both sides open for the passage of vessels. The appearance of the rotating span was changed during strengthening works in 1936, and the tapered shape's gone and replaced by square girders. The span at that time was fixed in position with bearing points constructed. This is just showing the full view of one page of the drawings. Now, it's one of a set of 16 of drawings from 1931 that we've on microfiche, microfiche being a microfilm system used to store files. And some extracts from the drawings. Just a key plan at the top shows the main structural elements of the plan. Now, all the main girders I've highlighted yellow, and the cross girders I've mentioned, I've highlighted blue there. They were renewed in 1936, and the rotating span was fixed in position at this time. The upgrade was to facilitate greater axle weights of the trains. And note also how span 5 differs, that's the left-hand side, differs because of a turnout located on the span. This will come onto that later on. And now the drawing at the bottom is just an extract just to illustrate the typical detail of the drawings. Very detailed, shows a cross-girder renewal arrangement in spans 2 and spans 4. Okay, and that concludes the historical element to the presentation. Coming more modern day, starting from the bottom of the bridge up, in 2012, we did foundation investigations, which comprise rotary coring, trial pits, dynamic probing, and geophysical surveys. This was part of a network-wide program initiated to investigate the foundations of our Irish Rail's bridges in watercourses, following the collapse of Broadmeadow Viaduct in Malahide due to scour in 2009. Now, we don't have construction drawings for Lough Atalia Bridge, so the investigation was carried out to ascertain the approximate level of foundations and correlated with our monitoring of the channel bed levels in our regular underwater scour monitoring inspections. The findings indicate the bridge cemented stone foundations, which are founded on medium dense gravels, sands and gravels, around 0.5 to 1 metre below the channel bed. In 2006-2008, our regular bridge inspections started to highlight deterioration in the piers below the bearing areas. The left-hand picture is 2006. And in 2010, an access scaffold was erected to permit a closer look during structural inspection. The top right shows splits and cracks of the pier masonry at and below the bearing. And you can see in the left-hand picture and the bottom right images that the masonry blocks, they're kind of visibly out of line. They're being pulled out. The bearings are defective, not allowing horizontal movement. Again, some more pictures. These are on the central pier with cracks running down 8 courses of stonework, and intervention was required with repairs. So our structural department designed a stitching tie bar repair for below the bearing areas of the piers. The photo on the left indicates the placement of the stitching bars, and the drawing on the right is a tie bar repair. Now the tie bars pass right through the piers, and they're anchored in the same fashion on the far side of the pier. So you'll see some images of the finished job. Now this is the works in progress here in 2011. Some of the steelwork been drilled and put in position. And this is the completed pier repair. The tie bars, as I said, pass right through the piers. They're anchored in similar on the far side. We then moved on to sorting out the bearing problems. The photo on the left is of span 5. There's a base plate split. The bottom flange of the main girder is bent and the support masonry is failing. In 2013, we replaced 6 bearings in total, 4 in span 5 and 2 in span 1. The bearings were all replaced in a 50-hour possession from a Friday night on 22nd of February to Sunday 24th of February. Now, that was in conjunction with a new station that's been constructed at Iarnród. Okay, in the picture on the right, you can see the new bearing being put in position. The structure's a lot of water traps, a lot of angles, a lot of crevices, leads to corrosion between plates. The girders also suffer corrosion from being in contact with wet timber. The photo on the left illustrates corrosion section lost to the main transverse girder. It's where it's been in contact with wet timber for a prolonged period. And the top right shows distortion, bending of plates with corrosion jacking. And the photo bottom right is a connection plate with the main girder where all connections are failing. So through 2012, a lot of steel repairs were undertaken by our bridge gang. These photos are just illustrative with many pictures, but it shows the extent of rivet replacement works and the plating repairs undertaken. The repair work exceeded the original estimated budget, which had been determined prior to commencing the work. And there's a lesson here, is you really don't know how bad it is until you have a thorough look. And much of the work was difficult to access, or much of the bridge was difficult to access. So we had to estimate, but when the shot blasting was done in advance of the repairs, it threw up a lot more work than anticipated. And more images here, the extensive repairs, plating stiffener repairs that the bridge gang did. And after this, the bridge was painted. On to the track work. Now in 2013, the proposal was to replace the timber longitudinal way beams with an embedded rail system of the design shown in the pictures. Now these embedded rail types have been widely used on bridges on our network, and this track upgrade was deferred because the budget was needed to finish the steelwork repairs. Now this gave us time to reconsider the track design, the embedded rail system would require extensive, costly conversion of the structure to carry the steel rail holder. Also, it'd be disruptive to train services with a shutdown a minimum of a week or more. The process would be to construct the steel channel and position the rail, and then pour a core-cast polymer embedding compound around the rail. A bit about the existing timber waving arrangement. It's quite complex. And to explain it in some images, the simplistic sketch at the top is just to show how the wavings in brown are supported on transverse timbers in blue that carry the decking. And the wavings are notched to accommodate transverse timbers, and it's a poor design detail. So, but it's necessary because of the proximity of the station platforms, which constrain the rail height. So they didn't really have much option but to make it the way it was. From above, again, it highlights the notched way beam on the left, and on the right you can see a small how small the depth of section is of the way beam that's been removed. It's far from ideal arrangement. The photograph on the left here, we see a decayed transverse timber. Now, this was a major deficiency in this design because the deterioration is hidden from above. The decay condition of transverse timber is a problem for maintenance of the track, and it's illustrated the diagram on the top right, where decayed transverse timber is represented in red. Because of the decay, the way beam and the rail deflects under wheel loads. This deflection here is measured cross-level difference, or the difference between measured against the opposite rail. The diagram on the bottom right is just to illustrate how the difference in cross-level can influence a vehicle chassis through what we call track twist. And a large magnitude track twist increases the risk of derailment through flange climb. So when the track replacement was deferred in 2013, we did thorough inspection and condition assessment of the timber track system from the scaffold. And here's an example of the condition rating traffic light report that was produced for the transverse timbers. Red needs replacement, amber's fair, and green is good. So using the referencing system we developed, you can see there in the box, we created work orders in our asset management system to replace all the red and amber timbers to keep the track system going. The work was managed through our work order system, which gave oversight of the work. And it's the first time we'd used our asset management system to drill down to this level of detail on Lough Atalia Bridge. And prior to this, we did not have detailed records better than someone had changed something somewhere in one of the spans. But this really gave us the oversight and the detail on where the defects were being changed. So the replacement of the poor transverse timbers in 2013 kept the track going, but it was still a priority to upgrade the track when budget allowed because of the risk of the hidden deterioration. So looking back now and rethinking the design, it was an opportunity to update my own views and to update the views of others working around me towards alternative, more sustainable track design solution. There are opportunities to adopt innovative solutions, and as designers, builders, maintainers of infrastructure, we, the engineers, have a duty to really understand and apply the 3 pillars of sustainable development in our approach. That's the economic, social, and environmental factors. For Lough Atalia track design, it was sustainability and consideration of life cycle costs that were key drivers in the redesign. And this is an image of an early idea that caught my eye. It's just from a trade magazine, March 2018, but it shows a full depth timber waving with no notches. And also note the red arrow pointing to the base plate. Now this base plate on every third base plate takes a check rail, which would offer some upgrade in terms of protection from derailment. Note also the silver clamping arrangement after every second base plate to prevent overturning of the waving. Now we did give this arrangement some thought, however, for Lough Atalia, it would have required a lot of additional work to achieve the clamping arrangement that's shown there. And also, we needed to consider what we were going to do in span 5. If you recall, span 5 is different. It's supported by 17 transverse beams, the legacy of where a turnout used to be situated on the span. So I then started thinking about synthetic timber material called FFU. We'd used it for the first time in 2017 to replace timber way beams on a 5-span bridge in Limerick of 135 metre length. And there's an article about that job in the online journal. Now on the Limerick job, we didn't have an opportunity to really exploit the material properties because we did a simple like-for-like swap. It was the first time we'd used FFU material, so we were cautious, but we did gain great knowledge and confidence in the material. The main issue Limerick was to eliminate the timber rot, and particularly the risk of hidden internal rot, as shown in the photo on the bottom right. FFU is fibre reinforced foamed urethane. It's an engineered synthetic material made of continuous glass fibre and polyurethane. The material was developed for the Japanese railways and introduced in Japan in the 1980s. Now, FFU sleepers can be worked and machined in much the same way as traditional timber, using standard tools and existing fastening devices, but it's much more durable than timber, and most importantly, does not rot. To manufacture FFU, glass fibre strands drawn through a pulling device and soaked in polyurethane. It's then cured at high temperature, resulting in high-grade, pore-free material. Now, FFU has been proven in research not to contaminate water sources, and a further environmental benefit is that FFU is 100% recyclable. Here's a table to compare some of the properties of the FFU with timber. FFU has better flexural strength and stiffness than timber, and it's better anchorage capacity than timber. The durability of this engineered material means you're able to plan for considerably longer service life than you were ever able to with timber. FFU has design life in excess of 50 years, based on research carried out by Japanese Railway Technical Research Institute. But FFU is not affected by UV light, and it retains its technical properties after many years of exposure. Also, from an asset manager's perspective, it's better material than timber to be in contact with the metallic elements of a bridge. Timber holds moisture, promotes corrosion, whereas FFU does not. So FFU material therefore performs better in special areas that are not convenient for maintenance. Now, I also looked at some images of FFU projects that the manufacturer's website has to get some inspiration what might be possible. Here's one bridge from the Netherlands. You can see the FFU is used as transverse sleepers, and the fixing down arrangement detail that's there. And here's another FFU example with transverse sleepers on a bascule bridge in Belgium. Now, the fixing down arrangement again is shown. It's all helped stimulate and develop ideas for the possibilities of using FFU. So in mid-2019, we'd actually decided on the design seen in the extract here. So we're using transverse FFU sleepers in spans 1 to 4 and a longitudinal FFU way beam in span 5. And you'll see images on the next couple of slides. But in terms of sustainability, the primary benefit, the choice of FFU comes through long service life, during which it's maintenance free. FFU is a manufactured material, so there's a lot of heat and energy involved in production. But when you consider the long service life of the FFU, the little maintenance that it needs, it comes out as a favorable, sustainable option. On top of this, an immediate saving in the change to FFU was the elimination of 118 tons of steel required for the rail holders in the embedded rail design. The installation work was all done at night in non-disruptive possessions, and the track returned for normal running of trains in the daytime. This sequence of pictures left to right shows the lifting of the rails and the way beams. The middle picture shows moving transverse timbers, and the right picture is the exposed rail bearers and girders of the structure. The FFU was installed sequentially in panels, starting one end of the bridge. The left-hand picture is an FFU track panel ready to lift in. You can see the angles for the fixing down arrangement. Also note how the sleepers are extended in length. This is to support a walkway grating that will be placed on top. And in the top right picture, you can see staff making up an FFU panel. The dust masks been worn and an industrial vacuum machine used because of glass fibre dust from drilling the FFU. It's not a big health and safety issue, but the dust can be an irritant to get in your skin and you rub it or you breathe it in. In the bottom right, you can see the rail base plate of a type manufactured by Svehag, which takes a check rail. This is the standard base plate we use throughout the bridge. And underneath there's a resilient pad to damp vibrations and a couple of 5mm FFU shims. So we shimmed up during installation so that we can make adjustments at the end just by removing shims to achieve the final rail levels. Here's the left-hand picture is FFU track panel been lifted in, and the right-hand picture shows our fixing down connection. So left-hand picture span 1 shows the siding road upgraded with FFU whilst the main line's still timber. And the picture on the right just shows how the FFU transverse timbers, they're extended to carry the walkway grating and the cantilevered, so they're not actually touching the structure on the far end, but it keeps air so as to keep air circulating and eliminate possible moisture traps on the bridge structure. And if you look closely, you can see regular rectangular rust patches at the intervals where the transverse timbers used to bear. And here is the span 5 FFU longitudinal way beam. Now it's 700mm width, made by bolting together two 350mm FFU pieces. So that fitted the base plates that we used, which were 580 by 200mm dimension. That's the drawing on the right. So the left-hand photo is the view from span 5 looking span 4. You can see the check rail is fitted here. It's completed in 2021. Contrast the difference in longitudinal FFU way beam and the transverse sleepers and the aerial picture on the right. In total, we put in 200 FFU transverse sleepers and 12 FFU way beams. And here's the before and after photographs of the track work. In conclusion, and with the deferral of the 2013 track renewal, what seemed a setback was turned into a positive outcome with the focus on rethinking the design for sustainability. The development of new composite materials coming into the sector is a really exciting area, but we have to understand the risks as well as the opportunities that innovative applications can offer. The interventions we made in Lough Atalia will sustain the asset for many more years of service. We've increased levels of safety and reliability as we have eliminated timber rot and the risk of track twist. Also for our customers, we've delivered speed improvements, which is an organizational objective. Also in ISO 55000, the term asset management is defined as enabling an organization to realize value from assets in the achievement of its organizational objectives. Well, we've certainly done that here in Lough Atalia. And just acknowledgements that there's too many people to mention, but just thanks to everyone who was involved with the works. And I look forward to any questions at the end of the talk. Thank you.
That's great, Colin. Very informative presentation. So I think we'll move on to the last speaker, which is Roy Harford from the National Transport Authority, who's going to speak to us on Connecting Ireland Rural Mobility Plan with a focus on the West region, developments in the West region. So I'll hand it over to you, Roy.
Yeah, hi, my name is Roy Harford. I'm a transport planner in the NTA Service Planning Division. So our role is to plan public transport services across the country, such as the routings, frequencies and timetables, and how services connect with each other as part of an overall integrated network. So we have a number of different work programs. We have Bus Connects, which covers the 5 cities, and our town bus program, which covers bus service in some of our larger towns across the country. But the one I'm here to talk about is Connecting Ireland, which covers everything else outside of the urban areas. So it's rural services and also interurban services. So it's about connecting smaller towns and villages into the nearest larger towns and cities. Connecting Ireland is a 5-year program of public transport improvements. It consists of a range of regional and local service improvements and expansions, and also aims to provide a line of funding dedicated to the development of non-conventional transport measures in areas which might not be suited to fixed route services. It's a plan-led intensification of the NTA's existing service review process, so we're not radically changing how we do things, but we're now looking at the country as a whole rather than just working on certain areas at a time. And we're also doing a lot more now because we've been given funding from the government to do more than we previously did. Some of the high-level objectives of the programme are to connect more people to more places via public transport, to provide an attractive service as an alternative to the car, and to provide a better integrated network of services. So just to give you some of the policy background to this, in 2018, our new national planning framework was published. It set out a number of national strategic outcomes, of which the first 4 of these in particular require us to have a good quality public transport network across the country. And one of these, you can see the second one here, is enhanced regional accessibility, which is the focus of this talk. So this is the policy which is set by the government, and the NTA as a state agency now is to try and see how it can implement these policies. So the NTA management tasked us with finding out what it would take for people to be able to live a reasonable quality of life in rural Ireland without having access to own a car. So it initially sort of started off as a research project. So this is our timeline so far. We started working on it over 3 years ago. We started off by analysing the existing network and the gaps within it, then putting together options on what changes we could make to address these issues. We then undertook extensive engagement with different stakeholders, such as county councils and other agencies and bodies, and then following their input, we refined our proposals and went to public consultation towards the end of last year. We're now at the stage where we're doing detailed planning for route proposals, and we're starting to implement them on the ground, and we're hoping to launch the first lot of these new routes from next month. So I'll just go into this in a bit more detail now, just the process we went through. So we started off by analysing all settlements from the 2016 census, from Dublin with over 1 million people all the way down to Mallintown, which is only 92 people. And we looked at the services and functions provided in each. And the reason we did this is because transport is not just a service on its own, it's a means for people to access other services. So when we're planning public transport, we need to focus on the places and services which people need to get to. For example, if you're living in a village which doesn't have a supermarket, a secondary school, a GP practice, for example, you need to be able to get to a town which has those facilities in it and get access to those facilities. So we then categorise all of the settlements across the country into a hierarchy of, we call them villages, local centres, county towns, regional centres and cities. This has sort of since been superseded by the regional spatial and economic strategy and development plan hierarchies, which have set out things like key towns and all. You can see just a diagram of that. As you move up to higher level settlements, you should have a greater range of services available. So the people in the smaller settlements need to be able to get to those larger settlements to access those services. We then looked at the existing public transport network to see what is already out there and what level of service it provides. So this is an example of this table from when we were working in County Roscommon. So you can see here it varies significantly. So you have some intercity routes passing through the county which have quite a lot of services per day, whereas there's other routes then which might only be running once or twice a week. So it varies quite a lot, or some might only be running during college term. We then mapped out all the regular routes, so those which operate at least once a day, 5 days a week, all year round, because you consider that anything that's below that doesn't really facilitate normal day-to-day life. Now, service once a day is still quite limited, but it was a starting point to come from. And this showed us then which places are currently connected to each other. But for us to actually see how useful those connections are, we need to go into more detail, because things may not be at times which suit people. So this is how you measure the connectivity. So we said if you're living in a village, for starters, is there a public transport route which runs to your nearby local centre or county town? Does it run every day? Is it within a reasonable journey time? And is there a return journey which will give you a sufficient amount of time to spend there? So for example, like if you're going to, you might have a service which takes you into your nearest centre, but if the only return journey leaves immediately, then you don't have any time to spend there to do anything. So it's not really of much use to you. And you can see some examples there on the right-hand side there. So for example, Castlereagh is connected to Roscommon town for the 440 bus. There's a few services a day, so people can travel in, spend a few hours there and come back. So there is a useful connection there provided to people. Whereas Ballintubber is also connected to Roscommon, but the service only runs on a Friday. So it's not particularly useful for people. So after we had done all of our initial analysis then, the next step was we moved on to trying to develop new proposals to address all these issues. So this is the approach we took. We started off by defining a regional network, connecting all of the regionals and larger settlements together. And we set targets of every 30 minutes, every hour, every 2 hours in each of these regional corridors. We then moved on to the local network, and we looked at what gaps are in the local network and developed new routes to address these gaps. And for local routes, we set a minimum target of 3 services a day, 7 days a week on all services. So we said there should at least be a morning service to take you in before 9 o'clock in the morning, and evening service back out at 5 o'clock in the evening to facilitate commuting for work and education. But there's also a need for at least one extra service during the middle of the day for people to get in for shorter trips, such as to go shopping or to socialise with others who don't want to spend the whole day there. This is just the minimum. In a lot of cases, we'll try to put in more than this if we can. For example, if the demand justifies it, or if the resources are available. So depend on the length of the route, if the vehicles running it are able to put in extra services, we're doing that where we can. So the idea is that the sort of mixture of regional and local services that would feed into each other. So people could take a local service from their village into the nearest county town and connect on there onto the more frequent regional services to get to somewhere like Galway or Dublin. Once we had put together a network, we then had we then had some stakeholder engagement. So we went to all 26 local authorities and had workshops with all of them and with a whole lot of different government bodies and agencies. So for example, some relevant ones to West, like the Northern Western Regional Assembly or the Western Development Commission, and different groups, and to see what their needs are. And they also gave us, we would have got a lot of, particularly with the local authorities, they would have given us useful information on where people want to get to. So we might have proposed a new route from a village to some town, but when we're talking to them, they say, well, the people in that village, it's not actually that town that they go to, it's a different town. So that's where they need to be connected to instead. And then we went to public consultation. After we got all the feedback from the stakeholders, we then refined the network and went to public consultation towards the end of last year. And because at the time it was all online, but we had a couple of different webinars and the information was all put up online, and we had a public consultation, but we got I think it was about 3,500 submissions in total. So yeah, this is just some of the information that went up, some of the different things that went out, and those things like adverts in regional papers and radio stations and all, to try and publicise a bit. Like while this is being planned on a national level, it's very much a local transport plan for everywhere outside of the cities and large towns. And we're not familiar with there's only a few of us who are working on this, and we're not familiar with everywhere in the country or the local transport needs for everywhere. So the public consultation was quite an important step for us to get all this local knowledge and information from local people, find out what are their needs. So as I said, we received 3,500 submissions, and we've made quite a good few changes to services based on this feedback. So these are just some examples. People go onto the website and click into their own county, view like maps, and there's a table for each county just listing the proposed service improvements. So now at the moment, we're now starting the implementation phase. So we're going into detail, putting together detailed timetables, deciding where stop locations will be, and we're getting. It's going to be it's a 5-year program, so it'll be next few years before we have everything done. We're hoping to start the first few services from June. So I think there's a few routes we're hoping to launch on the 1st of June. And just to give you some example of some previous things. So we introduced some network improvements in County Leitrim last year. And you see this was the patronage figures throughout 2019, and then would have dipped down during the pandemic. But when we introduced the service changes, we had an immediate increase in the number of people using it. So it's just proof if you give people good services, they will use it. And a more extreme example here is from the Dingle Peninsula, where to the west of Dingle, we previously had a service which was only running 2 days a week, which isn't a huge amount of use for people, and it was only getting around 20 people a week. We put in quite significant improvements than last year, where we put in a service running 7 times a day in each direction, all days of the week. So it was a huge increase from just operating 2 days a week. And you can see the passenger numbers have just shot up from about 20 a week up to 600 a week during the peak of the summer. And it came back down a bit after that because there's a lot of tourism use. But it just shows like there is demand out there for public transport in rural Ireland. And if you give people a good service, they will use it. So I'll just go to some of the proposals then for the Western region. So starting off with Galway then. So this is a map of the existing public transport network in Galway. So the blue sort of coloured routes or sea green coloured routes are their sort of regional bus services or intercity ones, and then the orange ones are more local routes. So some of the issues you can see here, so several settlements are not served. For example, you have Brownstown out in the west here, Glenamaddy, Williamstown, Hostka out in the east, and Woodford down in the south. There's no connection between upper and lower parts of Connemara. So for someone to get from Clifton down to Rossavale, their only options to go into Galway City and back out again, which isn't ideal. Also, if you look down to south from Portumna, there's no services going further south on either side of Lough Derg for people to connect to. And the northeast of the county, these settlements have no connection into Ballinasloe, where they have which would be the hospital serving this area, and it could also connect to the train service there, but there's no link there at the moment. So these were our proposals that we put together for it. So let's go to some of them. One of them was a new route from Roundstone into Clifton to connect Roundstone in. Now this was what we went out during the consultation, but since this now, we've actually made some changes to this, and we've extended this around to connect in with Carna with the 44 route here. So we're hoping to have a full connection, full coastal connection along the coastal layer of Connemara. As I mentioned, we were trying to connect the upper and lower parts of Connemara. So we're looking at a new route from Carrow and Rossaville through to Mam Cross. And again, since the consultation, we're now looking at extending this across through Cong and Ballinrobe up to Claremorris. Because again, there's no connection through this area of Galway and Mayo. So it'd be a new connection, which is not currently provided. And also on the eastern side of the county then as well, we're proposing a new route from Castlereagh down to Ballinasloe, which will pull in the settlements of Williamstown, Glenamady and Haskell, which currently don't have anything, and also provide a connection from all these areas into Ballinasloe, where they can access the hospital or a train service to continue on to Dublin or Galway. And again, to the south end of Portumna, we're proposing new routes either side of Lough Derg to connect towards down Nina on one side or towards down Limerick and Ennis on the other side. And there's a few other proposals there in red, which would be to just increase the frequency of services. And the green ones are the regional corridors, which again, we're hoping to increase the frequency of. So just moving on to Galway then, into Mayo. So again, you have the same issues. There's several settlements which are not there, for example, Lahardane, Money, Connellan. But in general, looking at this map, Mayo actually, it has quite a good network of routes. But the main issue here is just the frequency of services. And services might necessarily run at the times people need them to use. So these are our network proposals then for Mayo. So the two settlements I mentioned, Bunny, Connellan and Lahardane, we put in proposals to connect to them. One is an extension route, and there is actually a route going to Lahardane, which I think it runs 1 day a week at the moment. So we'd be hoping to increase that to 7 days a week, 3 times per day. And then the rest of the proposals here are to just increase the frequency of services. So the green ones are the regional corridors. We'd like to increase the frequency, as well as on some of the local routes, such as from Belmullet into Ballina, from Ballycastle into Ballina, along the 440 route here, which is, it sort of mirrors the railway line, but the difference is that it connects people from all these areas into Ireland West Airport and Knock, so provide better connectivity to there. We're also working separately with Irish Rail to try and get some frequency improvements on the railway lines here. So at the moment, there's some quite big gaps throughout the day, and some of the services, they're very much designed to get people to and from Dublin, so they mightn't serve local needs and local commuting needs as well. So we're working with Irish Rail to see if we can get some improvements to the services there at the moment. Something that's also worth pointing out here is the Route 450 that goes from Achill Island around to Louisburg. So we actually brought in quite good service improvements only, I think it was about 1.5 years ago. So previously there was only 1 bus a day coming from Achill Island through to Westport in the morning and back again in the evening. So it brought people in for commuting, but it was a very limited service apart from that. And it wasn't, because it was going in the morning out in the evening, it wasn't possible for people to travel the other way. So there's no way for people to make a day trip from Westport out to Achill and back. And Louisburg only had a service in certain days a week, I think. It wasn't every day. But about 1.5 years ago, we brought in new service improvements. And I think it's running about 6 or 7 times a day now in each direction, the whole way around. So that's quite a big change in services, because it allows people to travel in both directions, and it means they can travel in at different times of the day for different journey purposes and all. So while the route, as shown on the map, mightn't be changing, going from 1 trip a day up to 7 trips a day it has a big impact for the people and how useful the service is. And we've seen good strong growth in passenger numbers since then. And then finally looking at Roscommon. So so with Roscommon, there's a few settlements which aren't there. So for example, Loughlin here and Ballyforan here. Roscommon, because of its location sort of in the centre of the country, it has quite a lot of services going through it. But the issue here is that a lot of them are designed to get people to places like Dublin and Galway, and the focus on that and might necessarily meet local needs. So again, we're not proposing a huge amount of new routes here, but it's putting in extra services on existing routes to run at the times that they're needed for local journeys. So some of the proposals here, we are putting in some new routes here. So from Sligo down to Castlereagh, which are connecting Lough Lane, another connection from Castlereagh down to Ballinasloe, which I mentioned earlier in Galway. And we're also looking at a new route from Roscommon to Athlone, Ballygar and Ballyforan into Athlone. So connect all these settlements into both Roscommon and to Athlone. And the rest of the changes then we'd be looking at better service frequencies on existing routes. And then I thought I might just finish off with this here. So we had, unknown to us at the time when we were planning this, we now have a much increased need for connecting Ireland, as we have a large number of refugees currently moving into many towns and villages across Ireland who don't have access to private transport and will need to be provided with a reasonable level of public transport. So we've been asked to go to all of the locations of refugees, and we're doing that at the moment. And we're looking at prioritising and accelerating some of the proposals which will be needed to serve refugees in different locations. And we're hoping to roll out the first lot of some of these new routes from next month, some from the 1st June onwards. So yeah, thank you. I'm happy to take any questions.